November 8, 1942, Richmond, California. The acetylene torch flared to life in the pre-dawn darkness, its blue-white flame casting harsh shadows across the interior of hull number 440. The welder adjusted her protective hood and brought the torch tip toward the seam where two massive steel plates met at a precise 90-degree angle. In 6 hours, this joint would need to hold against the full pressure of the Pacific Ocean at depths that could crush a human skull. The woman wielding the torch had learned her trade exactly 14 days earlier. She had never seen the inside of a ship before October. She had been a secretary at an insurance office in Stockton until the recruitment poster caught her attention. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. What neither she nor the 300 other welders working that morning understood was that every bead they laid, every seam they completed, represented an act of industrial heresy that traditional maritime authorities had declared categorically impossible, fundamentally unsafe, and professionally unacceptable. The British Admiralty had issued explicit regulations forbidding welded construction on warship hulls. Vice Admiral Emery Land, chairman of the United States Maritime Commission, had expressed grave reservations in his private correspondence, noting that welding had never been proven reliable for hull construction at this scale. Master shipbuilders with 40 years of experience had stated flatly that welded ships would crack, leak, and ultimately fail under the stresses of ocean service. Yet here, in a facility built on mudflats just 24 months earlier, thousands of workers were betting America's supply lines on a technology that the entire maritime establishment considered dangerously experimental. The mathematics of victory were being written not in superior seamanship or better navigation, but in the molecular bonds created when electric current melted steel at temperatures exceeding 3,000 degrees Fahrenheit. The story of how welding transformed from forbidden technique to standard practice reveals a truth that would echo across the remainder of the 20th century. Sometimes the greatest breakthroughs come not from perfecting existing methods, but from completely abandoning them despite universal expert opposition. The resistance began in London during the autumn of 1939. As German U-boats began their campaign against British merchant shipping, the Admiralty confronted a simple mathematical problem. Cargo vessels were being sunk faster than British shipyards could replace them using traditional construction methods. Each merchant ship required approximately 6 to 8 months to build, using riveted construction, the technique that had dominated maritime engineering since the Industrial Revolution. Riveting involved precisely drilling holes through overlapping steel plates, then driving heated metal pins through those holes and hammering them into mushroom shapes that locked the plates together. A skilled riveting crew, working with perfect coordination, could install perhaps 100 rivets in a 10-hour shift. Each merchant vessel required approximately 1 million rivets if built conventionally. The labor intensity was staggering. A single riveted seam required a team of at least 4 workers. The heater maintained a forge where rivets were heated to cherry-red temperature. The tosser used long tongs to throw the glowing rivet to the catcher, who caught it in a metal cone and quickly positioned it in a pre-drilled hole. The riveter then used a pneumatic hammer to pound the protruding end into a secure fastening, while a 4th worker, the bucker, held a heavy steel bar against the opposite side to provide resistance. This process had to be repeated 1 million times per ship. The noise was deafening. The coordination required years of experience to master, and the pace, even with expert crews, limited production to a handful of vessels per year from any given shipyard. British naval architects had examined alternatives. Welding technology existed, primarily in pipeline construction and industrial fabrication. Arc welding, where an electric current created temperatures hot enough to melt steel, allowed 2 pieces of metal to be fused directly without rivets, without overlapping plates, and without the massive labor investment riveting required. But the Royal Navy had examined welded construction and rejected it categorically. Their technical manuals stated explicitly that welded hulls lacked the proven reliability of riveted construction. Admiralty regulations forbade the use of welding for primary hull structure on warships. The reasoning seemed sound. Riveted construction had been tested across thousands of vessels over more than a century. When a riveted ship suffered damage, the failure remained localized. A crack reaching the edge of one plate would stop at the rivet line rather than propagating through the entire hull. Welding created what naval architects called a continuous structure. The hull became essentially one massive piece of steel. If a crack developed, nothing would stop its propagation except the physical edge of the vessel. The potential for catastrophic failure seemed obvious to traditional engineers. Yet by late 1940, Britain faced a crisis that made traditional caution impossible. German submarines were sinking merchant ships at a rate that would literally starve the island nation within months if the trend continued. In 1941 alone, approximately 3.6 million tons of Allied shipping would go to the ocean floor. Traditional shipyards using conventional riveting methods would require an average of 230 days to build a single cargo ship. At that pace, Britain would lose the Battle of the Atlantic before new construction could replace losses. Desperation forced innovation. British maritime authorities approached American shipyards with a request for 60 cargo vessels based on a simple tramp steamer design. The ships would be slow, ugly, and utilitarian, but they needed to be built fast. Henry Kaiser, the 58-year-old construction magnate who had never built a ship in his life, secured the contract in December 1940. What happened next would trigger the most profound transformation in maritime construction since the invention of the steam engine. Kaiser's background was in moving earth and pouring concrete for massive dam projects across the American West. He had built the Hoover Dam, the Bonneville Dam, and the Grand Coulee Dam, using innovative techniques that traditional construction firms had dismissed as reckless. His approach to engineering problems was fundamentally different from that of master craftsmen who had spent decades learning traditional methods. Kaiser looked at riveting and saw not a time-tested technique but a production bottleneck. He had used arc welding extensively in pipeline construction. His crews had welded massive steel pipes that carried water across hundreds of miles under enormous pressure. Those welds had held. Why, he asked his chief engineer Clay Bedford, couldn't the same technique work for ships? Bedford had recently visited Ford Motor Company's assembly line in Detroit. He had watched automobile chassis moving down production lines with workers installing prefabricated components at each station. The precision was remarkable, the speed was breathtaking, and the workers were not master craftsmen with decades of experience. They were ordinary people trained to perform specific, repeated operations. Bedford returned to California convinced that ships could be built the same way. But the idea struck traditional shipbuilders as absurd. Ships were not automobiles. Maritime construction required skills passed from generation to generation. The notion that housewives, farmers, and secretaries could learn to weld ship hulls after 2 weeks of training seemed dangerously naive to experts who had spent their entire careers in shipyards. Vice Admiral Land examined Kaiser's proposal with deep skepticism. His private correspondence, preserved in the National Archives, revealed the maritime establishment's reaction. Welding has never been proven reliable for hull construction at this scale, Land wrote in a confidential memo dated January 1941. The British Navy forbids welding on warship hulls. Kaiser is proposing we bet America's supply lines on an unproven technology. Yet, Land also recognized desperation. German U-boats and surface raiders were destroying Allied shipping faster than any combination of traditional shipyards could respond. The decision to approve Kaiser's contract represented not confidence in welding, but acknowledgement that the alternative was certain defeat. The resistance intensified as Kaiser's Richmond shipyard rose from empty mudflats during 1941. When maritime inspectors visited the facility in May of that year, they were horrified by what they saw. Instead of the traditional riveting bays where teams of skilled craftsmen would work on stationary hulls, Richmond featured massive open areas where prefabricated sections would be welded together using workers who had never held a welding torch before arriving at the facility. John Riley, chief naval architect for Bethlehem Steel Corporation and a 30-year veteran of shipbuilding, inspected Richmond and filed a scathing report. Kaiser proposes to build ocean-going vessels using welding techniques that have never been tested on ships of this size, Riley wrote. He intends to staff his facility with workers possessing no maritime experience whatsoever. He plans to train secretaries and housewives to perform welding operations that typically require 6 months to learn adequately. Riley's conclusion was damning. This approach will produce ships that crack under stress, leak at the seams, and fail catastrophically in ocean service. Kaiser's ignorance of maritime tradition is exceeded only by his arrogance in assuming he can revolutionize an industry that has perfected its methods over centuries. The first test came in August 1941, when Kaiser's yards began hiring workers. The recruitment advertisements shocked the maritime industry. "No experience necessary," the ads proclaimed. "We will train you. Wages 20% above standard industrial rates." Thousands responded. Former secretaries arrived from San Francisco office buildings. Farmers came from California's Central Valley. Women whose husbands had joined the military needed work. African Americans fleeing racial violence in the South saw opportunity. None had maritime experience. Most had never seen a welding torch. Traditional shipyards recruited from established maritime communities where skills passed from father to son across generations. Kaiser's approach seemed to guarantee disaster. How could someone learn in 2 weeks what traditionally required 6 months of apprenticeship and years of experience to master? The training program Kaiser established revealed the genius of systematic simplification. Traditional welders spent months learning comprehensive skills. They could weld in any position, on any thickness of metal, under any conditions. They understood metallurgy, stress analysis, and structural engineering. Kaiser's instructors taught none of that. They taught specific techniques for specific tasks. A worker assigned to weld vertical seams on bulkheads learned only how to weld vertical seams on bulkheads. Another worker learned only horizontal deck plate welding. A third learned only the curved hull sections at specific angles. This extreme specialization allowed something remarkable. A complete novice could achieve acceptable proficiency in a specific, repeated operation within approximately 10 to 14 days of focused training. The quality of any single weld might not match that produced by a master craftsman, but when that same weld was repeated thousands of times, the worker's muscle memory and pattern recognition improved dramatically. By October 1941, Richmond employed over 10,000 workers. Fewer than 200 had any previous maritime experience. Among the new workers, a particularly revolutionary demographic emerged: women. The concept of women performing heavy industrial welding struck traditional maritime authorities as somewhere between laughable and dangerous. Welding required physical strength to manipulate heavy equipment. It required the ability to work in confined spaces deep in ship hulls. It required tolerance for harsh conditions, including extreme heat, toxic fumes, and constant noise. Yet women proved remarkably effective welders. Their generally smaller frames allowed them to work in tight spaces that male workers couldn't access. Their attention to detail produced consistently clean welds, and their willingness to learn quickly compensated for lack of prior experience. By mid-1942, women comprised approximately 30% of Richmond's workforce. They welded in the most critical locations, deep in the hull below the waterline where any defect would cause catastrophic leaking. They worked overhead welding deck plates. They assembled the most complex curved sections where hull plates met at difficult angles. The government created recruiting materials featuring Wendy the Welder, attempting to generate the same public enthusiasm that Rosie the Riveter had achieved for aircraft manufacturing. But Wendy never achieved Rosie's fame, perhaps because the work was less photogenic, or perhaps because it challenged traditional gender roles even more dramatically than riveting aircraft. The first Liberty, ship completed at Richmond in October 1941, required 197 days from keel laying to delivery. Maritime inspectors examined the vessel with intense skepticism. They checked every weld. They tested structural integrity. They looked for the cracks and failures that expert opinion had predicted would plague welded construction. The ship was ugly. The welds were visible as raised beads across the hull surface, lacking the smooth appearance of riveted construction. But the vessel was sound. It passed every inspection. It went to sea and performed exactly as designed. The second Liberty ship required 169 days. The third required 141 days. By spring 1942, Richmond was completing Liberty ships in 70 days on average. Traditional shipyards watched with growing alarm as this supposedly impossible approach achieved production speeds that matched and then exceeded their own highly skilled crews using proven riveting methods. The speed came from understanding welding's fundamental advantages. A riveted seam required 4 workers operating as a coordinated team. A welded seam required 1 or 2 welders working independently. This meant that where a traditional shipyard might have 100 riveters working on a hull, Richmond could deploy 300 welders simultaneously, each working on different sections without requiring coordination with others. The labor savings extended beyond personnel reduction. Welding eliminated the need to drill millions of precise holes. It eliminated the massive forges needed to heat rivets. It eliminated the deafening noise and physical violence of pneumatic hammering. The work was still dangerous and demanding, but it was simpler and faster. More importantly, welding enabled true modular construction in ways riveting never could. Richmond's yards fabricated entire bow sections, complete stern assemblies, finished cargo holds, and equipped deckhouses in separate areas of the facility. These massive prefabricated sections, some weighing more than 150 tons, were then lifted by crane onto the building ways and welded together. This parallel production transformed construction timelines. Traditional shipyards built from keel to deck in sequence, with each stage dependent on completing the previous stage. Richmond built everything simultaneously. While one crew welded hull plates, another crew assembled engines in separate workshops. When both were ready, cranes lifted the completed engine into the completed engine room, and welders secured it in place. Tasks that previously required weeks now took hours. By late 1942, the production acceleration reached levels that seemed impossible even to Kaiser's own engineers. In November, Richmond Yard No. 2 prepared to attempt something unprecedented. They would build a complete Liberty ship from keel laying to launch in under 5 days. Vice Admiral Land, visiting Richmond for an inspection, remarked to journalists that Liberty ship construction had improved remarkably, but still paled compared to true mass production achievements. Clay Bedford, overhearing the comment, took it as a challenge. He selected hull No. 440, which would be named SS Robert E. Peary after the Arctic explorer, for the record attempt. Starting at 1 minute past midnight on Sunday, November 8th, over 1,000 workers operating in carefully coordinated shifts attempted something no maritime authority believed possible. Every major component had been prefabricated. The bow section, comprising more than 50 individual pieces, had been fully welded and equipped with anchor hardware before assembly began. The stern section included completed steering gear. 4 cargo holds stood ready as massive rectangular structures. The engine, a 140-ton triple-expansion steam power plant, had been mounted on its foundation and tested before leaving the factory. For 4 days, welders worked around the clock. The sound of welding torches never ceased. Overhead cranes moved constantly, positioning sections with millimeter precision. Quality inspectors checked every weld immediately after completion. Any defect was corrected instantly, rather than accumulating for later repair. On Thursday, November 12th, at 3:30 p.m., just 4 days, 15 hours, and 29 minutes after the keel touched the building way, SS Robert E. Peary slid down the launching rails into San Francisco Bay. The ship was delivered for service 7 days after keel laying, setting an additional record of 7 days, 14 hours, and 32 minutes from start to full operational status. The crowd of observers included maritime officials, military officers, competing shipyard owners, and journalists from across America. Many had arrived expecting to witness either failure or a compromised vessel that looked complete but lacked functionality. What they saw instead was a fully operational ship requiring only minor fitting out before entering service, carrying 10,000 tons of cargo to the Pacific Theater. Vice Admiral Land, present for the launching, made brief remarks recorded by newsreel cameras. His words captured the maritime establishment's forced recognition that everything had changed. 6 months ago, I would have called this impossible, Land stated. Traditional shipbuilding wisdom accumulated over 3,000 years said you cannot build a proper ship in 5 days. Henry Kaiser has made traditional wisdom obsolete. The psychological impact on traditional shipbuilders was profound and immediate. The same yards that had dismissed welding as dangerously experimental just 18 months earlier now sent engineers to study Richmond's approaches. The president of New York Shipbuilding Corporation, one of America's oldest and most prestigious yards, visited Richmond in December 1942. His confidential report to the board of directors revealed complete ideological collapse. Kaiser has achieved what our industry considered impossible by refusing to accept our limitations, he wrote. He treated welding not as experimental but as proven technology from other industries. He trained masses of unskilled workers in weeks rather than cultivating generational expertise over years. The result is ships built in 1/10 the time at 2/3 the cost. We must either adopt his approaches or accept irrelevance. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. By early 1943, welding had transformed American maritime production. 18 shipyards across the country were building Liberty ships, using the techniques that had been considered forbidden just 3 years earlier. Average construction time had fallen from 230 days initially to just 42 days by mid-1943. The United States was launching 3 Liberty ships daily, more tonnage than German submarines could sink, but the validation of welding came with a complication that initially seemed to confirm the worst fears of traditional engineers. In the winter of 1942 to 1943, several Liberty ships began experiencing hull cracks. SS John P. Gaines broke completely in half on November 24, 1943, sinking with the loss of 10 lives. 2 more ships suffered catastrophic failures that same winter. Suspicion immediately fell on welding. Maritime authorities who had opposed the technique from the beginning claimed vindication. Here was proof, they argued, that welded hulls lacked the resilience of riveted construction. The cracks appeared at welded seams. The catastrophic failures occurred on welded ships. Kaiser's experimental approach, critics claimed, had produced exactly the disasters they had predicted. The investigation that followed revealed a more complex truth. Constance Tipper, an engineering professor at Cambridge University, conducted detailed metallurgical analysis of failed welds and intact welds from the same vessels. Her findings, published in 1944, revolutionized understanding of metal failure mechanisms. The cracks were not caused by welding defects. They were caused by the grade of steel itself. At temperatures below a certain threshold, the steel used in Liberty ship construction underwent what Tipper called a ductile to brittle transition. Above this temperature, the steel could flex and absorb stress. Below it, the steel became rigid and brittle, allowing cracks to form and propagate. Riveted construction masked this problem because cracks reaching the edge of one plate would stop at the rivet line, but welded construction created continuous structures where cracks could run unimpeded from bow to stern if conditions were right. The problem wasn't welding. It was steel composition, combined with North Atlantic water temperatures that fell below the critical threshold. The solution involved modifying steel specifications and adding crack arresters, riveted seams running the length of welded hulls, to stop crack propagation. These modifications, implemented by mid-1944, eliminated catastrophic failures. Of the 2,710 Liberty ships built, only 3 suffered complete hull fractures. The loss rate from all causes was 7.4%, comparable to pre-war merchant shipping despite the ships operating in active war zones under extreme conditions. The vindication of welding was complete. By 1944, women welders at Richmond comprised 40% of the production workforce. They were building ships that would serve reliably for decades beyond their designed 5-year lifespan. Many Liberty ships remained in commercial service through the 1960s and 70s. 2. SS John W. Brown and SS Jeremiah O'Brien remain operational as museum ships as of 2025, more than 80 years after construction, using the supposedly experimental techniques that the maritime establishment had declared impossible. The transformation extended far beyond Liberty ships. When Japan and South Korea rebuilt their maritime industries in the 1950s and 60s, they studied Kaiser's welding programs and adopted his approaches as the foundation of their yards. Every modern shipyard, whether building container vessels, oil tankers, or cruise ships, uses welded construction descended directly from the supposedly forbidden techniques pioneered at Richmond between 1941 and 1945. The workers themselves carried forward the confidence that wartime achievement had created. The women who learned to weld in 2 weeks and then produced ship hulls that survived decades of ocean service proved something profound about human capability. Traditional maritime authorities had claimed that shipbuilding required generational expertise, master craftsmen trained from youth, and decades of experience. Kaiser proved that systematic training of ordinary people could achieve extraordinary results. The secretary from Stockton, who had never seen a welding torch before October 1941, was producing structural welds in critical hull locations by November. Her welds, repeated thousands of times across dozens of ships, contributed to vessels that carried troops to Normandy, supplied forces across the Pacific, and served in global commerce for 30 years after the war. The story of welding's transformation from forbidden technique to standard practice reveals a pattern that would repeat throughout the 20th century. Established authorities dismiss innovative approaches based on lack of precedent. Outsiders unfamiliar with traditional constraints attempt the supposedly impossible. Initial skepticism gives way to grudging acknowledgement when results cannot be denied. And finally, the revolutionary approach becomes the new standard that the next generation of traditionalists will defend against future innovation. Vice Admiral Land, who had expressed grave doubts about welding in January 1941, testified before Congress in December 1944. His statement captured the complete reversal that evidence had forced upon expert opinion. "We began this program believing riveted construction represented proven reliability, while welding represented dangerous experimentation," Land stated. "We end it understanding that welding enabled production speeds and structural power, efficiency that riveting could never match. The ships, built using supposedly forbidden techniques, will outlast many vessels constructed using traditional methods." The mathematics bore this out. Between 1941 and 1945, American shipyards produced 2,710 Liberty ships. These vessels carried 10 million tons of cargo per month at peak production. They transported 2 million troops overseas. They delivered 859 million tons of supplies to Allied forces during the war. And they did it using welding techniques that traditional maritime authorities had categorically rejected just 4 years earlier. The ultimate validation came not from expert opinion, but from operational reality. Liberty ships survived torpedo attacks that would have sunk riveted vessels. They withstood storms that damaged traditional ships. They operated reliably in conditions ranging from Arctic convoys to tropical Pacific routes. And they did it while requiring fewer repairs and less maintenance than many vessels built using conventional methods. By war's end in 1945, the debate over welding had become historical curiosity. No serious maritime engineer would suggest returning to riveted construction for cargo vessels. The supposed advantages of traditional methods had been exposed as myths sustained by institutional inertia and resistance to change. The supposedly experimental techniques had become standard practice worldwide. Perhaps the most remarkable aspect was how quickly the transformation occurred. In December 1940, welded ship construction was forbidden by the British Admiralty and viewed with grave suspicion by American maritime authorities. By December 1945, welded construction was universal standard practice, taught in naval architecture schools as proven methodology and adopted by shipyards globally. 5 years. That's how long it took for a supposedly impossible, categorically dangerous, professionally unacceptable technique to transform from forbidden innovation to industry standard. 5 years from the first skeptical approval of Kaiser's contract to complete global adoption of methods that had been dismissed as reckless experimentation. The woman with the welding torch in hull number 440 on that November morning in 1942 couldn't have known she was part of this transformation. She knew only that the training had taught her to maintain the correct torch angle, move at the proper speed, and create a consistent bead that inspection would approve. She performed this operation hundreds of times per shift, thousands of times per week, contributing her small part to vessels that would help win a global conflict. When SS Robert E. Peary launched 4 days later, her welds were among the thousands that held that hull together. When that ship carried troops and supplies across the Pacific later that month, her work was tested against the full force of ocean storms and combat conditions. It held. It performed exactly as designed. It proved that the supposedly forbidden technique was not only acceptable but superior. The legacy extends beyond the ships themselves. The democratization of skilled work that welding enabled carried implications far beyond wartime production. By proving that complex manufacturing could be performed by trained workers rather than requiring generational craft expertise, Kaiser's welding programs challenged fundamental assumptions about labor, skill, and industrial organization. Women welders who learned their trade in 2 weeks and then produced critical ship structures demonstrated that capability was not inherent in gender or background, but could be developed through systematic training. African American welders working in skilled positions proved that racial barriers to technical work were social constructs rather than natural limits. The tens of thousands of ordinary people who learned to weld and then built ocean-going vessels showed that human potential exceeded conventional expectations when proper organization and training were provided. Commander Joseph Kenworthy of the Royal Navy, assigned to the British Admiralty delegation in Washington, watched American production with admiration and envy. His official reports, declassified in the 1980s, captured the British perspective on American industrial transformation. The United States is building merchant shipping at a rate that exceeds the combined capacity of the rest of the world, Kenworthy wrote in March 1944. Kaiser alone produces more tonnage monthly than the entire British shipbuilding industry. The approaches are crude by Admiralty standards. The ships are inelegant, but they float, they carry cargo, and there are thousands of them. That final observation captured the essential truth. Traditional maritime authorities had focused on perfection, on maintaining standards developed over centuries, on preserving craft traditions and proven methods. Kaiser focused on adequacy, on building ships fast enough to win a war, on achieving sufficient quality through systematic processes rather than master craftsmanship. Adequate, multiplied by thousands, defeated perfection, multiplied by dozens. The supposedly crude welding techniques that offended traditional sensibilities produced more ships, faster, cheaper, and ultimately more reliably than the time-tested riveting methods that experts had insisted were superior. The story concludes not with ships, but with understanding. The greatest obstacles to innovation are rarely technical. The welding technology existed in 1940. The training methods that enabled rapid skill development were known. The modular construction techniques that accelerated production had been proven in other industries. What didn't exist was willingness among established authorities to question their own assumptions. The British Admiralty forbade welding not because evidence demonstrated its inferiority, but because lack of precedent made it seem risky. American maritime officials doubted Kaiser not because his methods were proven failures, but because they contradicted traditional practice. The transformation from forbidden to standard required not new technology, but new thinking. It required looking past surface differences to see underlying similarities. It required treating maritime construction as a manufacturing problem rather than a craft tradition. It required training ordinary people in specific skills, rather than cultivating comprehensive expertise over years. It required questioning whether impossible truly meant impossible, or simply meant nobody had figured out how yet. That lesson, demonstrated in the shipyards of Richmond and validated by 2,710 completed vessels, remains relevant wherever industries face challenges that conventional wisdom claims cannot be overcome. The Liberty ships are mostly gone now, scrapped decades ago or resting on ocean floors, but the revolution they represented endures in every modern shipyard, in every manufacturing facility that uses welding, in every training program that teaches specific skills quickly, and in every engineer who questions whether expert consensus represents truth or merely represents the limits of current imagination. The secretary from Stockton who learned to weld in 14 days and then helped build vessels that survived decades of service proved something that traditional authorities had claimed was impossible. Ordinary people, given proper training and opportunity, could achieve extraordinary results. Skills that supposedly required years to develop could be taught in weeks through systematic instruction, and techniques that established experts declared forbidden could become standard practice when desperation forced innovation and results validated the approach. From November 1940, when Kaiser signed his first contract, to November 1942, when Robert E. Peary launched after less than 5 days of welded construction, to September 1945, when the last Liberty ship was delivered, the transformation was complete. The forbidden torch had become the industry standard. The supposedly experimental technique had proven superior to methods refined over centuries, and the workers who wielded those torches, many of them women who had never held industrial equipment before the war, had built the cargo fleet that helped win the greatest conflict in human history. That achievement stands as testament to a truth about human capability and industrial possibility. The ships themselves mattered less than what their construction proved. Complex products previously requiring master craftsmen and months of labor could be manufactured in weeks using systematized processes. Industries resistant to change for centuries could be revolutionized in months when necessity and innovation combined. And the greatest breakthroughs often came from questioning whether impossible truly meant impossible or simply meant not yet attempted with proper methods and sufficient determination. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.